Welcome all. The previous class we have discussed on that term symbols for diatomic molecules. So today class I will discuss some more about this term symbols for diatomic molecules. Basically, uh, I like to discuss about the examples. Okay, so let's say we discuss that how to calculate that term symbols for diatomic molecules. That is, let's say L value 0, 1, 2, 3. Then this is sigma, this is pi, this is delta, and this is this values. Okay, so this one we have discussed, and let's if we take the examples one by one, we will take examples and we will discuss, and also we will discuss about of that ground state for diatomic molecules, and also we will discuss that allowed transitions for diatomic molecules. Okay, so let's discuss some examples. Let's say I think we have discussed about the O2 and some molecules we have discussed in the previous class. H2 also I think we have discussed. So today basically let's take about H2 minus. Okay, so for that I have already shown that heliums, hydrogens, heliums, lithium, beryllium, boron, carbon, and nitrogen. For all this, that MOT, that MO diagrams will be unsymmetrical from the center. So, and whenever that for s orbitals, this is for p orbitals. Okay, for p orbitals, that here p orbitals, this MOT will be that unsymmetrical. Okay, for s orbitals everywhere that is same. That is, you see that s and s. So if s orbital, then there is no problems, because everywhere case that is one orbital only there. So how many electrons? One hydrogens, another hydrogen. So how many electrons here? One s1 and another electron. So this is one s2. Okay, here one s1. So peel the electrons. Here two electrons are there. Here one electron there. So if you peel it, then this. Okay, this is sigma and this is sigma star. Okay, so that since it is in the sigma, and you see that this H2 minus, so H is like this, here minus is there. So here that SCOs is present here, center of symmetry is present. So G and U will look. Okay, so part, and since here, since if that orbitals is at sigma, if electrons is at sigma orbitals, then that this value is always that L value is always sigma. Okay, so this is sigma first because electrons is at sigma orbitals. So this is sigma will get. Now we will see that G rate or un G rate. Yes, so electrons, you see that electrons are at, so you see that sigma, sigma star, pi, and pi star. So this is G, this is U, U, G. Okay, so G, U, U, G. So here see that electrons where is there. So one electrons, since this is sigma, so G, another electrons for another G, and G into G is G. Okay, that we have discussed in the previous class. And U. Okay, this is sigma star, this is U. Okay, so only one electron there, so one U. Okay, so now this is G, and here this is U. So G into U is U. Okay, so this is G rate. Okay, now if that electrons is at sigma orbitals, then it is always positive, irrespective of what is 2s plus 1. We will not care about it. If it is sigma orbitals, this is always positive. Okay, no negative will come if electrons is at sigma orbitals. Okay, now next, that is, now we will calculate the 2s plus 1. Okay, so here that s, how many, what is the value of s? So we will count how many unpaired electrons. S means we, because these polypile electrons, they will cancel with each other. So this is plus half, this is negative half, so they will cancel with each other. So this is unpaired electrons 1, and for this value is half, so this is half. So s is half, then 2s plus 1 value will be 2 into half plus 1. This is cancel it off, then this will 2. So this will be 2. Okay, so this is that term symbols for this H2 minus electron. Okay, similarly if you take other examples, let's take other examples. I think carbon we have discussed, then let's say carbon 2 minus. Okay, so here also you see that carbon has 2s2, sorry, carbon is 2s2 2p2. Yes, so now this 2s electrons that will be completely filled, so that will cancel out each other. Okay, so whenever this is there, only look the 2p orbitals, because s orbital is fully filled, they will cancel with each other, cancel with each other. Okay, so p orbitals, that is 1 2. Okay, so two electrons are there, 1 and 2. Okay, so how will you know that orbital diagrams? This is carbon dioxide, so only oxygen and sulfurs we are getting the symmetric orbitals from that center. So here unsymmetrical, so I will draw that unsymmetrical molecular orbitals. Okay, this. Okay, so here one each, one carbon we have that 2s2 2p2, and other carbon we will do that 2s2 2p4, because two electron extra is there. Okay, so one I will do that p2, another I will do that p4. Okay, now, so since this is unsymmetrical, okay, so what I'll do, so first here that so this is always, you see that for antibonding orbitals, first is pi star then sigma star. Okay, for antibonding always first pi star, then we'll get the sigma star. Okay, okay, so now we can join here, join here, join here, join here. Okay, now since this is carbon dioxide unsymmetrical from the center. Okay, so now this is pi, then I will do here sigma, because this is unsymmetrical. Okay, then I will do pi, because this is unsymmetrical for from the center. Center means from here, see we get here, then this will pi will get, here we get sigma, so this is unsymmetrical. Okay, so fill the electrons. Here we have the 2 electrons, here we have the 4 electrons, 1 2 3 and 4 electrons. So total how many electrons? For 6 electrons. So fill it, 1 2 3 4. Okay, 5 6, 5 6. Okay, so this is that pi orbitals, this is sigma orbitals. So we know that p orbitals, how will you fill? This is 1 minus 1 and this is 0, because this is px, this is py and this is pz. We always sigma orbitals pz will go, and pz sigma orbitals only that value is 0. Okay, pz only 0, that we will feeling like this, right? So this so this is px, this is pz and this is py, and for pz always you say 0 and this is 1, this is minus 1. So pz value is always sigma orbitals and this value is always 0, L value is always 0. Okay, so now we will calculate that L value. So how many electrons? So this is 1, how many electrons? 2 electrons, plus this is value is minus 1, how many electrons? 2 electrons. Okay, and this is what is the value? 0, how many electrons? 2 electrons. Okay, so this is 2 and this is minus 2 and this is 0, so total value will be 0. So if L is 0, then now whenever this L is 0, then we always to look that whenever L is 0, go for the two conditions. Okay, one conditions is L is 0 and always this is sigma, always this is sigma. Okay, this is for all the case sigma, and difference will comes here, that now we will look that if electrons in that is molecular orbitals each in sigma orbitals. Okay, if electrons are sigma orbitals, like here you see that if electrons were sigma orbitals, then on that case what you look that only plus will come, only positive value, only positive will come. Okay, where positive will come, that we already discussed that. And if electrons is in electrons in molecular orbitals, if electron is in molecular orbitals, if electrons in molecular orbitals of pi orbitals, okay, if electrons in molecular orbitals of sigma orbitals, then always positive will come. And if it is pi orbitals, then we will go for the 2s plus 1. Okay, if this value is 1, then positive value will comes, positive will comes, and it is 3, then it will come negative. Okay, so these things we have to look at. So here that sigma last electrons are where at sigma orbitals are there, so this always come the positive values. Okay, so if we look here, that this will be that L is 0, so 0 means this value. Okay, so now this is you see that this is G U U G, we know that G sigma star pi star. So this is G, this is U, this is U, this is G. Okay, so G, so this is G, so how much, this is for 1, that is G, another one for G, G into G is again G. Okay, because we have to discuss that G into G, G, U into U, G, G into U, then U come, and U into G, then U come. So that we have discussed in the previous class. So this will be G into G, so this will be G. Okay, now since this is at sigma orbitals, this is always positive. Okay, now that S value, what is the S values here? So all are paired, means no unpaired pair electrons, so S value is 0. If S value is 0, then 2s plus 1 value will be how much? 2 into 0 plus 1, that is equal to 1. So this get 1. So this is the term symbols. Also that if that condition is that whenever that electrons is at sigma orbitals, this value will be always positive on that times. No need to look that whether this condition, so you no need to look that pi orbitals, then we will look that whether this is positive or negative, 2s plus 1. If it is at electrons at sigma orbitals, then automatically we will write the positive value. Positive value means what I mean, positive value that I mean is that here. Okay, this value will be always positive. Okay, also we can see that since S value is 0, so that value will always 1, and if 1 is also, if 1 is come, then that is always positive. Okay, so that the things. Now we'll take other examples so that we clear more. I think for O2 we have discussed in the previous class, so now we'll discuss about of O2 plus. Okay, because O2 we have discussed and C2 we have discussed in previous class. Now we'll discuss for O2 plus and O2 minus. This one we will discuss, and NO we will discuss. Okay, these are the examples we will discuss. After that we will take about of the ground states. Okay, so for O2 plus, so I have discussed that for O2 and this fluorine F2. Okay, for here that molecular orbital diagrams will be symmetric from the center. Okay, for p orbitals, I'm not talking about s orbitals. For s orbitals, everywhere that is same. Okay, so now for O2 and NO. Okay, so for O2 I'm drawing. So see that okay, so O2 we know that oxygen, that is 2s2 2p4. Okay, so now s orbital will not look, only 2p4. Okay, another is also O2, that is also 2s2 2p4, but we see that O2 plus means one electron is less, so we will take another, either here or here, anyone will remove one electron. Okay, so I am removing plus here, then that will be 2p3. Okay, s orbitals you will not look because this is fully filled. Okay, so now make the orbital diagrams. Only I am looking for p orbitals because s orbitals cancel with each other, so from that we will get no values. Okay, so we will look only for s orbitals. If p and s orbital is there and s orbital is fully filled, then only look for p orbitals. Okay, so how many electrons? 4 electrons. So 1 2 3 4. Okay, here how many electrons? 3 electrons. 1 2 3. Okay, and since this is O2, this is symmetric from the center. Okay, so first we will build that antibonding orbitals. So antibonding orbitals always this is pi star will comes, pi star will comes, then this value will comes. Okay, now this is symmetric from the center, so here we are getting that pi, then here also I will get the pi. Okay, after that sigma. Okay, so now we'll fill the electrons. Okay, so now we'll fill the electrons. So how many electrons? 1 2 3 4 5 6 7. Okay, so 1 2 3 4 5 6 7 electrons. Okay, so now we know that we will give that 0 and 0, so that is what g. So it will look like this: sigma, sigma star, pi star. This is sigma is always g, then it's a g g u u g. Okay, so this is sigma, this is pi, this is pi star, this is sigma star. Okay, so electrons, so wherever that electrons are there, they actually cancel with each others. For L values also, this is how, this is value is 0, this is 1, this is -1, so they will cancel with each other. So unpaired electrons we will look, then this is, what are the values? Since this is pi star, then this is 1, -1, and this is 0. Okay, so this is, so value of L is 1. How many electrons? 1 electrons, so this value will be 1, so L is 1 here. Okay, now so if L is 1, so you know that 0 1 2 3 4. Okay, so this is sigma, this is pi, this is delta, this is psi. Okay, so this is the things. So now we have get that we get L equal to 1, so L equal to 1 is which value? This value we will get. Okay, so this will be that pi. Okay, now whether this is zeroed or unzeroed, that is whether we look or not, for that we will look for COS. Okay, cos. So O2, we are talking about O2 plus. Okay, so O2 plus, like this will be there. So here that we have that COS is present, so it is zeroed or unzeroed, we will write. Okay, now we will write zeroed or unzeroed. How will it look? So this is sigma is G and pi is U, and sigma pi star is G and sigma star, that is U. Okay, so pi star is G. Okay, and sigma star is U. Okay, so now that electrons is at pi star. Okay, so electron is pi star and that is G, so one electron is there, so G. Okay, so this will be, value will be the G will come. Okay, now since we have discussed that one properties, what that is, if L not equal to 0, then plus or negative, positive or negative values not come. Okay, So these positive and negatives are only for if L equal to 0, then look for positive or negative. Okay, and we also discussed that if L equal to 0 and electrons is at sigma orbitals, then always positive value will comes. Okay, so these are three things we have already discussed, that if L is 0 and so I will look it. If L equal to 0 and electrons is at pi orbitals, then look for positive or negative. Okay, and if this is the 1, you have to remember this 2, this is 3. Okay, so these are things. If L equal to 0 and electron at pi orbitals, then look positive or negative. That how we look, I already discussed that. Okay, 2s plus 1, it is 2s plus 1. If it is 1, then this is positive. 2s plus 1, that is 3, then that will be negative. Okay, so that we have to look. Okay, and if L is not equal to 0, I mean that L is equal to 1, 2, 3, then positive and negative value will not come. Okay, and if L equal to 0 and electron is at sigma orbital, then always positive value will come. Okay, so these things have to remember. So here L is 1, so positive and negative value will not come. Okay, so this is L is not equal to 0, so positive and negative value will not come. So here we will not write positive or negative. Okay, now next. So 2s plus 1, so s value how much? How many unpaired electrons are there? So only one unpaired electrons are there. Okay, so s is equal to half. So 2s plus 1 value will be 2 into half plus 1. This is cancelled off, then 2. So this is the term symbols. Okay, so likewise we will calculate it, and we will look another examples, that is OSET. So we have discussed on this, and sorry for I think I'll discuss here that O2 plus we have discussed. Another is we'll discuss on O2 minus. O2 minus, another is NO we will discuss. Okay, so next example will be O2 minus. Okay, so for this again, this is that orbitals. So here is 2s2, 2p4, another also this is 1 for oxygen, another oxygen is 2s2, 2p4. Okay, so one electron extra, so I will write here, or you can write anywhere. Okay, so one electron extra, so I will write 2s2, 2p5, and this is 2s2, 2p4. Okay, so I will make that molecular orbitals 1, 2, 3, 1, 2, 3. Okay, so this is oxygen, so COS is there, and it is that oxygen fluorine that is symmetric from the center. Okay, so first I will draw that antibonding orbitals. Antibonding orbitals always like this. Okay, always first will be pi star. Okay, then we will go to first we will write that antibonding, because for antibonding it is fixed, always pi star then sigma star. Okay, now For oxygen, that is oxygen and fluorine, that is symmetry from the center. So here is a pi star, then here also I will have that pi star or pi. Okay, because this is COS from the, so this is symmetry from the center. Okay, so this is the things. Now I fill the electrons here. 5 electrons here, 5 electrons. So 2s2 orbitals will be cancelled with each other. So I will not taking on that. 2p5. So 1, 2, 3, 4, and 5. This is 1, 2, 3, 4. Okay. So just fill the electrons. How many total electrons? 2, 4, 5, 5, 4, 5, 2, or 5, 4, 9 electrons. Okay. Total is 9 electrons. Okay. So 9 electrons. Let's fill. Okay. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so total 9 electrons I filled. Okay, now first we will calculate that L value. So L value, which are the fully filled, they will cancel with each other. So you can see also here you see that sigma orbital 0, this is 1, this is -1. Okay, so fully electrons we will not take because that will be cancel each other. If you want to check also you can check, that is 2 into 0 plus, okay, 2 into 1, okay, plus 2 into -1. Okay, and another is here this is 1, this is 0, this is, sorry, this is -1, this is 0. Okay, so I have taken up to this. So here 2 into 1 plus -1 into 1. So total add it up, then what the value? This is 0 and this is plus 2 and this is -2 and this is plus 2 and this is -1. So this cancel off. Okay, so L value will be, that is 2 minus 1, that is 1. Okay, so L value we get 1. So if L value is 1, then we see that if L value is 1, then we know that 0, 1, 2, this is sigma, this is pi, this is heat, and this is 3, then this value. So whenever this L value is 1, then no positive and negative value will come. Okay, so this pi will come, so positive negative will not write. So now we'll look, yes, this is center, this is COS is present. Okay, so now we will look on whether zeroed or unzeroed. So this is pi star, so you know that sigma star pi star, this is G, this is U G. Okay, so this is electron is pi star is G. Okay, so G is there, so here G, 1 electron 1 G, and for another 1 G. Okay, this is again G, so G into G comes to value G, and this is again G, then all will be G. Okay, because we know that G into G is G, U into U, that is G, G into U, that is U, and U into G, that is U. So this we have discussed in the past class, this we have to remember. Okay, so this value will be, whole value will be G, so whole value will be G. So here we will get that G. Positive negative we will not write because L is equal to 1. Okay, so next 2s plus 1, this value we need. So what is the value of S? How many unpair electrons are there? That is 1, because pair electron they will cancel with each other. Okay, because this represent that half and this represent that minus half, so if you add it, then they will be 0. Okay, so S is half, so 2s plus 1 will be 2 into half plus 1, this cancel, this will go to 2. Okay, so this is 2. So this is that term symbols for O2 for O2 plus. Okay, so for O2 minus. Now we will look another examples, that is NO. So NO. So how that molecular orbital diagrams for this? So for N, that is you see that 1s2, 2s2, 2p, 3, and oxygen, that is 1s2, 2s2, 2p4. So these are poly filled, so we will not take only p3 orbitals and p4 orbitals will take. Okay, and for this also that orbitals will be that, let's say 1 2 3, it says 1 2 3. Okay, so now here first we will fill that pi star. Okay, now here we will look. So for this NO also, this is symmetric orbitals. Okay, it means here also we will get that pi orbitals. Okay, so fill the electrons, here 3, here 4. Okay, so here the 3 electrons are there, 1 2 3, here 4 electrons, so 1 2 3 and 4. Okay, so total electrons 3 3 6 plus 1 7. So 1 2 3 4 6 7. Okay, so this is sigma, this is pi, this is phi star, this is sigma star. Okay, so this is, so here what are the electrons are there. So first we will calculate that L values. So for L values, this will be that see, this is 0, this is 1, this is minus 1, and this is 1, this is minus 1, and this is 0. So L value we can calculate it. Here 0 means all will be 0, so 2 into 0, let's say plus here that 2 into 1 plus 2 into minus 1. Okay, plus here 2 into, sorry, that is 1 into 1. Okay, so total if you calculate, then this is 0, this is plus 2, and this is minus 2, and this is plus 1. So this cancel off, then L is equal to 1. So if L is 1, then that is this. Okay, and now because this is 0 1 2 3, then L is sigma phi delta and this. Okay, so now for this case, when L is equal to 1, this values, and now we look for 2s plus 1. Yes, because for if L is 1, then positive negative will not comes. Another thing is that here NO. Okay, here this is NO. Sorry, this is NO. Okay, so from here if you go to this, then we will get nitrogen, and from here we will get oxygen. So here COS is absent. COS is present only that if O. From here we get oxygen, here we get oxygen, here we get space, here we get space. Means all side we get that same things when COS is present. But here the different things is coming from here nitrogen, here oxygen. So different, so COS is absent. Okay, so if COS is absent, then G and U value will not come. So not, you will not look G and U value. So if COS is absent, not look for G or U. Okay, so that I will be told in the previous class. Also today class also I have discussed that if COS is absent, not look for G or U. Okay, here also I think I have mentioned. Okay, here I not mentions. Okay, so if COS is absent, then not look for G or U. So here G or U I will not write. Okay, so plus positive also not write because L equal to 1, only 2s plus 1. So 2s plus 1. So what is the S value? S value is here that is, and pair electron is only 1, because pair electron they will cancel with each other. So S is half, so 2s plus 1. So 2 into half plus 1, this cancel off, this will be 2. So this will be the 2. So this is the term symbols for this NO. Okay, likewise, so some conditions, some that if I give the summary for calculating term symbols for diatomic molecules. What things we have to look? Uh, what things we look? First, we look that first we remember that orbitals. This is very crucial. Orbitals, where this is that sorry, that is from like says hydrogens to helium. Hydrogen, helium, although there is no p orbitals is there. So wherever p orbital is there, I will write lithium, beryllium, boron up to nitrogen. Okay, here only oxygens and chlorine. Okay, here is symmetric orbitals will do symmetric orbitals from center. Okay, here sorry, this is unsymmetrical orbitals. Sorry, unsymmetric orbitals from center. This is symmetric orbitals from center. Okay, so here that how will we do that? Let's say I'm doing that. This type of orbitals we will draw, and if it's symmetric orbitals, then how we do that? Let's say this is this symmetric will be there here too, then here also too. Okay, so this type of orbitals will be here, symmetric orbitals from the center. Here pi, here sigma, here sigma. Okay, from center. Okay, or I can do so from this center. This is symmetric. Okay, from here this is pi, here sigma, so no symmetry. Okay, here symmetry is there. Okay, so that first orbitals we will look for all these things for like lithium, beryllium, boron, wherever p orbital is there up to nitrogen, that is unsymmetrical. Means one time you go to pi star, then you will get another sigma, not pi. Okay, but symmetric means one time you will get pi star, then the second case also you get that pi. One is pi star, one pi, means symmetry. Okay, this one things you have to remember. And secondly, the orbitals you have to look that whether this L is 0. L, I will look that value of L. Okay, 1. If L equal to 0, answer is L is not equal to 0. Okay, if L is equal to 0, then there is also another two conditions. If L is 0, then you have to go for two conditions. Okay, if electrons is at sigma orbitals, okay, then what we will look, then always positive value. Okay, and if electrons is at pi orbitals in MO, okay, MO, then we will go for two conditions. If 2s plus 1 is equal to 1, value is 1, that is 1, then positive value, and if 2s plus 1 is equal to 3, then this will get negative. Okay, so these are the conditions if L is equal to 0, and if L not equal to 0, then what you will get? If L not equal to 0, then no positive or negative value, no positive and negative will come. Okay, this positive and negative will not come. Okay, if L is not equal to 0. Okay, and also you know that L values, and we also know that L values, what are the L values? Okay, and another things, also we know that L, that is 0, 1, 2, 3, this is sigma, this is pi, and this is delta, this is this. Okay, this also you have to remember. Okay, and another things that cos, and now another is if COS present for COS. Okay, so if COS absent, then no G or U will come. Okay, so this we will not write, G or U will not come, or I can write simply G or U will not come. And if COS is present, then G or U will come. And how G or U will comes, that we will decide it by sigma star, pi, and pi star. Okay, this G sigma is always G, and then we write U, then G. Okay, likewise you will do another things from here also. You remember that G into G is always G, and U, okay, U into U is also G, and G into U is U, and U into G is U. Okay, so this you have to remember for this. So these are the four conditions. While if you look for that diatomic molecules, whenever you want to write that term symbols, there these three conditions, these three things you have to look. One, and this is 2, and this is 3. Okay, so these three things you have to look whenever you will go for that term symbols for diatomic molecules. Okay, first orbitals we will look, then we will look for that value of L. Okay, so that is the conditions, and then for COS is there. Okay, so because we are writing that term symbol, that is this. Okay, here G or U, so how G or U, we understand that. Then 2s plus 1, this we have to write as always, s value will calculate, and here you will write positive or negative. Okay, this is the term symbol. So how this we have to write, we have to apply these conditions for all the molecules, then you will get these term symbols. So these are the four conditions. Okay, so these conditions we have to look it. Okay, so we can screenshot it and understand the what are the conditions you have to look whenever you are calculating for the diatomic molecules. So now we will go to next, that is for that calculations of the ground states. Next our topic is calculation of ground state from that ground state term symbols. Ground state term symbols. Okay, so likewise we have calculated for that coordination complexes how we would calculate the ground states. So similar way here also we will use that same trick, only adding up one extra point, that is here first we will look that symmetric, that orbitals has to be symmetric, means that G is symmetry, so that has to be G. Okay, for ground state that term symbol should have the G first. After that we will follow that all the conditions of the likewise like Hund's rule, all these things, that is first S value should be highest, then L value should be highest. Okay. First condition is that has to be that G. Okay, so let's take the examples to understand more. Let's take, if you discuss about of O2. Okay, so O2 we have discussed in the previous class how to do that. Let's say O2, so this is 2s2 2p4. Okay, so 4 electrons, here also oxygen, here also oxygen, so 4 electrons, so I will fill the 4 electrons, 1 2 3 4, this is 1 2 3 and 4. Okay, so here so this is always symmetric, so 1 2 and this is 1. Okay, so fill the electrons. So total how many electrons? 8 electrons, so fill all this. So 1 2 3 4 5 6. Okay, 1 2 3 4 5 6 7 8. So 1 2 3 4 5 6 7 8. Okay, so 2 electrons are here. So what are the possibilities? So here we will look that if the electrons is like this, other also possible. So let's say, so if I fill the electrons here the same way, 1 2 3 4 2 3 and 4. Okay, so now we look 1 2 3 4 6. Okay, now if I look at 7 and 8 like that. Okay, I'm taking that what are the all possibility. Okay, this also possible, also this also possible. Because for oxygen that is always symmetric. Okay, that we have to remember that point. Okay, so 1 2 3 4 2 3 and 4, so 3 4 5 6 7. Another is this way also possible. Okay, so from here we understand, we calculate that which is the ground state. So these are the three cases. Let's say this is case 1, let's say this is case 2, let's say this is case 3. So from here if you calculate the term symbols, then what is the term symbols for this case? Let me calculate by this. So what are the term symbols for this case? Okay, what are the term symbols? So first we will calculate for L value. So L value is here, so this is 0, this is 1, this is -1, this is 1, this is -1 and this is 0. Okay, so this will cancel it off, then this will be that we have discussed in the previous class for oxygen, how do you calculate term symbol. So this is L value will be, this is 1 into 1 plus 1 into -1, 1 into -1, that value will be that 1 and -1, that is equal to 0. So L is equal to 0, so 0 means this value will comes. Okay, now since this is come and this is in pi electrons, so if it is pi electrons, then we will look for 2s plus 1. Okay, so whether that is 1 or 3 if 1 is positive and if 3 is negative. Okay, so here that how many non-pair electrons are there for S? How many non-pair electrons? 2. So 2 into that value is half, that is going to be 1. So if S is 1, then 2S plus 1 will be 2 1 are 2 plus 1, that is going to be 3. So if 3, then that is going to be negative value. Okay, so this will be negative. Okay, first things. And since this is O2, so COS is present, so we look for zeroed or unzeroed, and we know that for pi star, okay, this is the pi star. Pi star, this is G, and this is also again G, so G into G is G. So this will going to come G value that we have discussed in the previous class, how to get this value. Okay, or we can took that conditions for that this one we will look with, then we will understand that. Okay, so this one I have done here, how this value is coming. Okay, this one. Okay, so GU, and now I will calculate for 2S plus 1, that is 3. So this is the 3 values. Okay, this is the one case. Okay, now for here we will calculate that similarly with the term symbols. Here we will calculate, then the same things here, that this all will be the cancel it up, so I'm not doing that. So now we can calculate it. Okay, so how this value will come, L value. So this is 2 into this will be 0, this will be 1, this is minus 1, so 0, that will be 0 because 0 into 2 0, and this is 2, then this is minus 2. Okay, and this is 1, this is minus 1, this is 0. Okay, so this value will be that 2 into 1. Okay, so this is the value, so this is 2 minus 2 plus 2, that is equal to this cancel, this L is equal to 2. So if L is equal to 2, then what are the values we see that that we can say that L equal to, let's say 0 1 2 3, then this is I say that sigma, this is pi, and this is heat, this delta, then this is this value. So this is 2, then this is this value. Okay, so this here what will come, that these values. Okay, after that if this value L is not equal to 0, then we will not write plus or minus, so plus minus will not comes. Okay, now we look for G or U. So this is about of which we are talking, this is about of oxygen. Okay, so G or U will be comes. So G or U will come. So how we look whether G or U? Sorry for that. Okay, G or U. So this is from there. So you see here electrons are at pi star. So then it's G, and G into G is G. Sorry, this is not for our case this. Okay, so this is G because this is pi star. So another is G, here also G. So this is also again going to get the G value. Okay, so this is also G, and this plus minus you will not write because L is not equal to 0. So now 2S plus 1. Okay, so how many unpaired electrons are here? How many unpaired electrons? So no unpaired electrons means that S is equal to 0. Okay, because S is equal to 0, because this is plus 1 and minus half, that will plus half minus half will cancel with each other. So S is equal to 0. So if S is equal to 0, then 2S plus 1, that is going to get value 1, and 0, so plus 1, that is 1. Okay, so this is the term symbols. Okay, so for this case 3, now we will calculate here. So here first we will calculate for L values. So L values, this is 1, this is, so this is 0, this is 1, this is minus 1, so 0, so 2 into 0 plus 2 into 1 plus 2 into minus 1. Okay, and this value also, this is 1, this is minus 1, this is 0. Okay, so that is plus that is 1 into 1. Okay, and this is plus 1 into minus 1. So calculate the whole value. This is 0 plus this is 2. Okay, this is minus 2. Okay, this is plus 1. Okay, this is minus 1. Okay, so this cancel, and this also cancel. So total L value is 0. So if L value is 0, then that is this value will comes, first things, and secondly we will go for G-rate or unG-rate, because this is O2, COC is present. So from here, that what you see here, that G or U, this is pi star, so this is G and this is also G, and G into G is G, so G-rate G will come. Okay, now plus or minus, how will you look? So see here, this is pi star, this is pi star orbital. So if electron is pi star or pi orbitals, then we will go for 2s plus 1. So if 2s plus 1 is positive or negative, that is 1 or 3, we have to look. Okay, so this s is, we see that this is likewise this way, and this is opposite way, so this is minus half. So this is again going to get the value which is 0. Okay, so s is 0, then 2s plus 1 will be 2s plus 1 will be s equals 0, 2 into 0 plus 1, that is 1. So if is 1, then that is positive, and this value is 1. So this is the terms for this O2. Okay, so now from here that we understand that which is the ground states. Okay, now we look that which is ground state from this case 1, case 2 and case 3. How will you compare for ground states? For ground states, so for ground states, ground term symbol for diatomic molecules, first condition is first. Okay, first preference, first look for G-rate, that is G. So if G is there, then that will be the first preference. Okay, for G-rate. If all are G, then go for second terms, that is first we will look S, that is highest value. Likewise we will do it, S is highest, and if this is also all are same as, then go for L of highest value. Okay, so these are the conditions for that. If you are looking for diatomic molecules, first look for G-rate. Okay, so if G-rate is there, then that is the ground state. If all are G-rate, then go for S highest. Okay, and if all are S, if all have the same S, then go for L highest value. Okay, from that only these three conditions is needed. From here that we, if the threes, then we'll understand that which is ground state or which is excited state. Okay, from here, so we will decide that which is G-rate or which is the ground state. So for here we look that first we will go for G. So all the cases G is there, all the cases G, here also G, here also G, here also G. So look for G-rate, so all are G-rate, then we will go for next conditions, then we will go for that value of S is highest, then L is highest. Okay, so now we will go for S. So here is 3, here is 1, here is 1. It means that 3 means S value will be 1, because 2S plus 1, that is going to be 3, then 2S is equal to 2, then S is equal to 1. For this case, let's say 2S plus 1 is 1, then 2S is equal to 0 and S is equal to 0. So here S is 3, means this value is highest, so this is the ground state, because all are 1 1, so this is the ground state. Okay, if you compare in between these, okay, which are the more close to the ground state? So for both the cases, this is 1 1. So now we will go for L value. Okay, so for this L value is how much? This is L value is 2, here L value is 0, so this will be the more close to ground state. Okay, so first we will look for G. Next, if all are G, then we will go for S, and if S also everybody is same, then we will go for L value. Okay, so this is the more close to ground state, and this is the second excited, this is the first excited, this is the ground state. Okay, so likewise we determine that which is the ground state and which is the excited state and which is the first excited states. Okay, And one more things, so likewise we can go for other examples also. So like I did for O2, we can go for other examples like hydrogen cases also we can take. Any other examples we will take. First we will take calculate the term symbols and apply these three conditions. First that has to be G, and after that S value highest, then L value highest. Likewise we can calculate that which is the ground state, or which is the first excited state and which is the second excited state. Okay, so now next our next topic is that rules for electronic transitions. So what are the rules for the electronic transitions? Okay, so unlike that other than diatomic molecules, there we look that first rule. So rules for electronic transitions. Okay, so first rule is Laporte rules. So Laporte rules, we know that is delta S should be, sorry, the delta L. Laporte rule means delta L. Sorry, delta L that has to be 0 or plus minus 1. So unlike that other ways only we say that plus minus 1, but for diatomic molecules the 0 is also allowed. Okay, so that L should be, that L, delta L means L2 minus L1, that has to be 0 or that has to be 1 or that has to be minus 1. If any of these value will come, then that is allowed electronic transitions. Okay, that's the Laporte rule says. Next is delta S, that is spin selection rules. Okay, that is spin selection rules. Spin selection rule, here always the delta S has to be 0. Okay, then that is allowed transitions. And third is that parity selection rules, that is G to G, there will no electronic transitions not allowed. Okay, so U to U, that transitions will not allow. If G to U, then transitions will allowed, vice versa. Okay, similarly like that. Okay, so G to U only transitions will be allowed, G to G not allowed, U to U not allowed. Okay, and third condition, that is for sigma terms only. Okay, because only here that positive and negative will come. So if positive is there, positive to positive transitions will be allowed. Okay, and negative to negative only transitions is allowed. But one is positive and other is negative, then transitions is not allowed. Okay, so these are the conditions for that whether transition is allowed or not allowed. Okay, so now if you take the examples, let me take that examples. Let's say that delta G plus and 1 and this is plus. The G and plus and 1. So whether here that transition is allowed or not. So first that positive to positive transition is allowed. Okay, this is okay. And this is G to G transition is not allowed. Okay, because G to U only transition is allowed. So this is not allowed transitions. Similarly, if I go for I to 2, let's say this sigma and this is 2. Okay, here transitions is allowed or not. How will you look? So first this L value is how much? 5, means that is 1, and this is 0. So delta L that should be 0 plus 1 or minus 1. So here that L value is, so anyone will calculate that L1 minus L2. Okay, that is 1 minus 0, that is 1. So 1 is there, so this is allowed. So for L value, that is Laporte is allowed. And here that delta S value has to be 0. Okay, so here S value is how much? Okay, so delta S 2s plus 1 is 2, then 2s is equal to 1. Okay, and S is half. Here also S will be half, so S2 minus S1 has to be 0. So yes, this is half minus half, that is equal to 0. So this is also allowed, this is also allowed, so this is that allowed transitions. Okay, similarly we can go for, so we can look that delta L whether it is satisfying or not, that is plus minus 1 or 0, and delta S always has to be 0, and positive to positive or negative negative only allowed for sigma terms. Then G to U is allowed, but G to G or U to U is not allowed. So these uh, conditions we have to look. And other examples if I take, let's take that this, and that is G, and this is 3 2, let's say that is G and 2. Okay, whether this is allowed or not. So first things that from S value we understand that I think it is not 0, first things. Okay, because another G to G also not allowed. Okay, so this is not allowed transitions. Okay, because that here also you see that 2s plus 1, that is going to be 3, so 2s is equal to 2, so S is equal to 1, but here 2s plus 1, that is 2, so 2s is equal to 1, so S is half. So I don't think S2 minus S2, that has to be S2 minus S1, that has to be 0. So whether here that 1 minus half, that is going to half, so this is not equal to 0, so this is not allowed transition. So Lapete also, spin also forbidden, and Lapete also, Lapete is fine. Lapete is fine, but GG also forbidden, because G to G is not allowed, U to G is allowed. Okay, so here also problem. And next, if you take the examples, also you can take that examples, that is this 5 3 and 2, that sigma 1. Okay, here, so it is not there. Okay, here maybe G, or let's say it's positive is there. So now here that transition is allowed or not. So here that things are not there, so you will not look here, because G also you also not here, so you will look only for L value, that is here, that is for this is 1 and this is 0, so this is 1. So Lapete is allowed. Let's check that spin. So here 2s plus 1, that is 3, 2s is equal to 2, and s equal to 1. Okay, here that 2s 1, that is 1, and 2s is equal to 0, so s is equal to 0. Okay, so that delta S has to be 0. So here we see that S2 minus S1, that is 1 minus 0, that is 0, but we know that you needed delta S has to be 0 for allowed, but here the delta S is equal to 1, which is not equal to, here the delta S is equal to 1, so which is not delta is equal to 0, so this is forbidden. Okay, so this is forbidden. So likewise you can look that, so for diatomic molecules, for electronics, for allowed transactions, so I'll write for diatomic molecules, allowed electronic transitions are what? First condition is that Lapete, that is what, that delta L should be 0 1 and minus 1. Second conditions, that spin, and that what we say, that actually that is spin selection rule. Okay. in selection rule, that is delta S has to be 0. This is the second conditions. If all these conditions satisfied, then only that is allowed transitions. Okay, and next is G to U is allowed. Okay, but G to G or U to U, these are not allowed. Okay, this is the third conditions. And fourth condition is if that for that is sigma terms, that is plus to plus will be allowed, and negative to negative will allowed, but positive to negative will not allowed. Okay, so these are the four conditions, I think. So these are the four conditions. So all the four conditions